At some point, maybe in high school, I started reading more and more books about space and astronomy and got really engaged in that. I think part of it also was I realized I really liked math, but also really liked art. I mean, space is beautiful. And the sort of combination of that was something that drew me. So there are different types of light that we can see. There's optical light, which is like what our own eyes see, visible light, but you can have light everything from X-rays down to radio, and different astronomers study those things. So I mostly work with finding explosions that we first see in visible light. There are many types of ways that stars can burp and hiccup and explode throughout their lives. Perhaps the most common type of explosion we like to talk about is a supernova. So this is what happens when a massive star reaches the end of its life, so it starts to collapse in on itself. And that'll eventually trigger an explosion, and it will throw out material, several times more material that's in our own sun. One of the big questions in astronomy is actually where all of the elements come from. So we think that some of these elements come from supernova, things like iron and nickel and slightly heavier elements than that. But a big open question had been, where do the heaviest elements in the periodic table actually come from? Things like gold and platinum and uranium, things which we do think are crucial for certainly forming things like Earth and life itself. And one possibility for where they came from is that they are produced in supernova explosions, but it could be somewhere else, and that somewhere else could be neutron star mergers. If you take two neutron stars, which are actually the remnants of stars that have previously gone off as supernovas, and if you have two of those, eventually they'll sort of spin around each other and get closer and closer and closer together and eventually merge. And that process will, again, throw out lots of material. It's been predicted that neutron star mergers could produce the heavy elements in the universe for decades, but it had never been observed. All of that changed in August of 2017. LIGO is the Laser Interferometer Gravitational Wave Observatory. And what it is actually a set of few detectors here on Earth that are trying to detect gravitational waves. Gravitational waves are essentially, you can think of them as space wiggling. And space wiggling when very heavy things are moving quickly around each other. Back in 2015, they made the first direct detection of gravitational waves. They got the Nobel Prize in Physics for that in 2017. And what they found, though, was two black holes spinning around each other and eventually merging in space. However, I'm an astronomer. I study light. Black holes are black. In August of 2017, I got a text message saying that LIGO had found a new source. But this one was different. It was very high signal, and it was a neutron star, not a black hole. LIGO, when it finds a source, it essentially can tell you where it's coming from a patch on the sky that's about the size of 150 full moons. But we also found out that that patch of the sky, it was only going to be visible for about an hour at the beginning of the night. So suddenly we had about 5 hours to prepare for 1 hour to find something that no one in the history of the Earth had ever seen before. As it turns out, from when the sun set, it took us about 15 minutes. And it was incredible. It was an image of a galaxy, and slightly offset to the upper left was this new dot that 6 months ago wasn't there. 24 hours later, it changed dramatically. It had sort of plummeted, so it was now very red. And normal supernovae do not change on timescales that quickly. So we knew at that point it was a new explosion like none we'd ever seen before. One of the big conclusions of our observations is that neutron star mergers do produce the heaviest elements in the periodic table. We know that conclusively now. The big question at this point is, could Earth have formed somewhere else in the galaxy? Were those elements present there as well? My name is Maria Drout. I study explosions in space, and I'm excited about the unexpected.